All right, so chapter 21, nuclear chemistry. So think about all the chemistry that you've been learning about. It's kind of, regular chemistry. And kind of regular chemistry, what we focus on is the electrons, right? We never change the identity of an element. If there's a gold, it stays a gold. Its charge might change, but its identity doesn't. So there's a change in bonds or electrons. Well, when you get to nuclear chemistry, it's a bit different. So when you're talking about nuclear chemistry, you're talking about a change in the nucleus. And remember, the number of protons is what the identity of the element is. So here we're actually talking about changing the identity of an element, right? Hydrogen into gold or something crazy like that. So think back to Chem 101 and your atomic symbols. So right here, it's the symbol, right? So if this is carbon, you'd be a C, a nitrogen would be an O or an N, a manganese, it'd be an Mn, all that kind of stuff. And then remember, what determines the identity of the element is the number of protons, and the number of protons is this bottom left number, also known as the atomic number. And remember that the number of protons determines the identity of the element, right? Hydrogen always has one proton, helium always has two, and so on and so forth. And then this top left number here is the mass number. And remember, the mass number is the number of protons and neutrons. And remember, a change in just the number of neutrons changes the isotope of the element. And then, since one's protons and neutrons, if you want to figure out number of neutrons, you just subtract the two numbers. So, for example, carbon 14, you see that in this case, I didn't put this bottom left number down here, but you should know how many protons it has anyways, because using your periodic table, you can tell that carbon always has 6 protons. If you have an atom that has 6 protons, it is by definition carbon. So 6 protons, since this top left number is 14, 14 minus 6 is 8, so 8 neutrons. And since there's no charge on this thing, we know it has 6 electrons as well. So just to give you an example of some other symbols we're going to see, we can also denote a proton as a P, and then a 1 and a 1, because it's one proton. A neutron as a lowercase n gets the 0 on the bottom left because there are no protons, and a 1 because there's one neutron. And then finally, an electron gets 0 in the top left because it's not a proton or a neutron, and then it actually gets a -1 because it's kind of the opposite charge of a proton.